All right, so we're still on stoichiometry. We got our quiz last Friday. Well, we didn't do spectacular. I think computer part like average was in the 60s. The written part, I quit. I quit grading them. There was a lot of them that were blank. Obviously, we need more work, and you know when that work's going to be? It's going to be Wednesday, and then at lunch on Thursday because I think on Friday we might be having our exam. If it's not Friday, it'll be early next week. It's time for a test. So it's time to know stoichiometry. If you don't know it, time to move on to the next thing. All right, so I'm going to go over like one of each, not all of these. I'm just going to go over one, but in class I'll go over as many as you want. But I'm just making this video for maybe somebody's at home sick but they don't want to fall behind. So they'll get to watch this video and kind of see how I do it. You can see in 5, 6, and 7, these it says balanced because these equations are already balanced. The first 4 are not. So I've noticed we had trouble balancing equations. So here we go. So I'm going to start with balancing the equation. All right, there's my thing's going to work. So the problem's asking how many moles of aluminum oxide, Al2O3, are produced from 4 moles of aluminum. Well, this equation here is not balanced. You can see O3, that means there's 3 oxygens. O2, that means there's 2 oxygens. 2 and 3 are not the same. That's not balanced. We got to have the same amount of oxygens and aluminums on both sides. So let me go over here. So you look at 2 and 3. The common number is 6. So I'm going to go way over here if it'll follow me. Keep going. Keep going. There we go. Too far. All right. So I need 6 oxygens. To do that, I'm going to go 2 Al2O3. Boom. Now 2 times 3 gives me 6 oxygens. Arrow. Now I got O2. That's only 2, but I need 6 to be balanced. So 3O2. Because now 3 times 2 is 6. Boom. Our oxygens are now balanced. 3 times 2 is 6. 2 times 3 is 6. Now we got to take care of the aluminums. Over here, we got 2 aluminum oxides. For every aluminum oxide, there's 2 aluminums. So 2 times 2 is 4. All right, that's an easy fix. So I come over here. My thing will follow me. There we go. Keep going. There we go. So I need 4 Al. And voila. Now we have 4 aluminums over here, 4 aluminums over here. 6 oxygens on the left. 2 times 3, 6 oxygens on the right. We are balanced. And then I'm going to show you how to do it. All right, so now this one is insanely easy because you can see if my thing will work. All right, how many moles of aluminum oxide are produced from, move please, there you go, 4 moles of aluminum? Well, look, 4 moles of aluminum will react with 3 moles of oxygen to make 2 moles of aluminum oxide. So 4 moles requires 3 moles of oxygen gas to make 2 moles. So the answer is 2. But, you know, to do it, to show you how to do it. So I always start out with this. You know, it's like new rule, line times line. So we always start out with that. Whatever number they give us, and they're giving us this right here, 4 moles of Al. That's what they're giving us. Whatever they give you in the problem, put it right here in the top left first. So 4 moles Al. All right, so now we use the mole ratio. 4 moles of aluminum for every 2 moles of aluminum oxide. Since Al is on the top left, Al is going to go on the bottom right because we want to get rid of aluminum. So basically, whatever you put, whatever unit, so it's moles of aluminum, whatever you put on the top left, it's going to go on the bottom right. And the number is 4. So it's 4 Al. And the one we want is right here. How many moles of aluminum oxide? And the number is 2. So it's 2 Al2O3. All right, so now it's the same. Top times the top divided by the bottom. 4 times 2 is 8. 8 divided by 2 equals 2 moles of Al2O3. But like I said, we didn't even have to do that because we already saw with the mole ratio, 4 moles of aluminum are going to create 2 moles of aluminum oxide. And that's what we got for the answer was 2. So that one was pretty easy. Maybe I'll do another one. Hold on. So here we are with number 2. Let me get my little thing. All right, see if my cursor will go. There we go. All right, so how many moles of H2O are formed from 6 moles of hydrogen gas or H2? This is not balanced because you can see the hydrogens are fine. H2, 2 hydrogens. H2, 2 hydrogens. Good so far. O2, 2 oxygens. O, 1 oxygen. That's not balanced. 2 and 1 are not the same thing. So I'm going to go here. So to get 2 oxygens, that's a pretty easy fix. I'm just going to make 2 waters, 2 H2Os. So now, boom, now I got 2 oxygens. Arrow. All right, so now my oxygens are fine. So I got 2 H2Os, so I got 2 oxygens. 2 times 1, that's 2 oxygens. Now I got 4 hydrogens. So my O2s are fine. I got 2 on both sides. But now I got 4 hydrogens over here, only 2 on the left, so that's an easy fix. 2H2. So now 4 hydrogens over here. 2 times 2 is 4 hydrogens over here. 2 oxygens, and 2 times 1 is 2 oxygens. So everything is now balanced, and I'll show you how to do it. All right, so now I'm going to show you the way that always works. Now this is another simple one. I probably should have done a different one. All right, if my thing will move, there we go. All right, so the question's asking how many moles of water are formed from 6 moles of hydrogen gas? 6 moles. How many we get? So we start like this. This is the way that will always work, even though this one you should be able to do in your head. All right, so whatever the question gives us, and it's giving us, the given is 6 moles of H2. That's going to go top left every single time. 6 moles of hydrogen gas, H2. Since H2 is in the top left, hydrogen gas is going to go in the bottom right. And how many moles? What's the mole ratio? 2. So it's going to be 2 H2. And now what's the ratio for water? Oh, it is also 2. The ratio is 2 to 2, which equals 1. 2 H2Os will go be on the top because that's what we want. Now, since the ratio is 2 to 2, 1 to 1, and it's saying we got 6 moles of hydrogen, since the ratio is 2 to 2, we're going to make the same exact amount of water. We're going to make 6 moles of water, but to prove it, we'll do this. So now it's top times the top. 6 times 2 is 12. 12 divided by 2 is 6. 6 moles of H2O. Remember, we could have also done this method, since it's a nice, easy number, to go from 2 to 6. So it's saying if we have 6 moles of hydrogen gas, so we're supposed to have 2 moles of hydrogen reacting with 1 mole of oxygen, we'll make 2 moles of water. But to go from 2 to 6, what do you have to do? Now you could say plus 4, but don't do that because you'll get it right for this one, but you'll screw it up. I mean, in this case, it would actually work. But remember, you're always multiplying. To go from 2 to 6, you're going to multiply by 3 times 3. So to find out how much water, you also have to multiply times 3. So 2 times 3 is 6. You're going to get 6 moles, just like we got over here. Now, if I ask you, hey, how many moles of oxygen gas would be required to make that 6 moles of water? Well, that's the same thing. Well, remember, there's really a 1 here. Even though there's not a 1, there's really a 1. You'd have to multiply that 1 by the same number times 3. It would take 3 moles of O2. All right, so there's going to be your 6 moles is going to create 6 moles of H2O. All right, I'm moving on to some more difficult problems. All right, so now on to the gram to gram. So the last ones we were doing were mole to mole. And let's see, is my thing, there we go, it's moving. So now it's gram to gram, the mass of one substance to the mass of another. All right, so it's going to be this, it's just got an extra step. All right, so the question is how many grams? Well, first of all, look, there's extra credit, and there will be extra credit on your test if you calculate the percent yield, and right here, here's the formula. Percent yield is the actual yield. That's the number you'll get in the lab. So if you do an experiment and you find the mass or the weight of the product, that's your actual yield that you saw, that you measured yourself in the lab, divided by the theoretical yield, which we're going to do here with our math, doing the stoichiometry, times the number 100, and that's going to give you the percent yield. All right, and then I have a thing that I'm going to provide for you that shows you how to do it as well. All right, the question is how many grams of aluminum oxide are produced with 10 grams of aluminum? Remember, once again, this is what it's giving us. The problem is giving us 10 grams of aluminum. So we're going to start out with line times line. Since it's giving us 10 grams of aluminum, that's going to go up here in the top left. 10 grams AL. All right, since we got grams up here, grams is going to go on the bottom and 1 mole is going to go on the top. Because step one, we got to turn, what is 10 grams of aluminum? We got to convert it into moles first. And 1 mole of aluminum weighs 26.98 grams. 26.98 grams. Notice the G here and the G here. If grams are top left, grams are going to be top or bottom right. And it's grams of aluminum. So it's the same. It's kind of hard to read with all that stuff right in there. All right, so by doing this, 10 times 1 is 10 divided by 26.98. So that's going to be a number, that's going to be a decimal. But we don't have to calculate that yet. We can just keep going. Times. Now we do the mole ratio. So now we're going to look. We want to go from aluminum to aluminum oxide. So aluminum, and you look at the balance equation here, it's 4 to 2. Since we want to get rid of aluminum, it's going to go on the bottom. So 4AL is going to go on the bottom. And what we want, this is what we're trying to figure out, aluminum oxide will go on the top, and its number is 2. So the ratio is 2 to 4, it's like one half. 2 moles of aluminum oxide are made from 4 moles of aluminum. So 2 moles of Al2O3. When we do that, that's going to give us the number of moles of aluminum oxide. But the question's not asking for how many moles, it's asking for how many grams. So we got to convert this into grams. Since we want grams, we have moles and we want to get rid of grams, mole is going to go on the bottom. 1 mole, and then we look right here, of aluminum oxide is 101.96 grams. 101.96 grams. All right, so now let me get the calculator out. You multiply all of the top. 10 times 1 is 10, times 2 is 20, so it's 20 times 101.96. 20 times 101.96 equals 2,039.2. I'm going to run out of room. Maybe I won't. 2,039.2. All right. Divided by everything on the bottom. 26.98 times 4 times 1. So just 26.98 times 4. Let's see what that is. 26.98 times 4 equals 107.92. 107.92. And now we just do this simple math. 2,039.2. 39.2 divided by 107.92 equals, we're going to get 18.89 grams of aluminum Al2O3. And I almost forgot. So now, okay, we did all our math. So from 10 grams, where's my cursor? There it is. From 10 grams of aluminum, we can make 18.89 grams of aluminum oxide Al2O3. Remember, for extra credit, what's the percent yield? Well, this is actually easy part. The actual yield, which is right here, 17.8. So that's what we measured in the lab. I just made up that number, but that'd be pretty close. So it's the actual yield of 17.8 grams divided by the theoretical yield. How much should you get? And you usually don't get, usually your actual yield is lower than your theoretical yield because things don't always work perfectly. You usually get less product than you predict. So it's this divided by this times 100. All right, so now let me look at my calculator. So 17.8 divided by 18.89 equals that times 100. And our percent yield equals 94.2%. So we got 94.2% of the product that we predicted. Not quite 100%, just a little bit under. Let me do another one. All right, so I'm not going to do another one because I'm already up to 15 minutes. I don't want to go any longer. So anyways, here's some more extra credits. For those of you that have the gram to gram stoichiometry down pat. If you want some more extra credit, here's your opportunity. Finding the limiting reactant. And I'm going to have a little worksheet that shows you how to do it and explains what it is. It's basically which reactant is going to run out. Because, is there exactly the right amount of both? Usually there's not. Usually one is in excess and the other one is going to run out. So to find out which one of these is going to run out, I'm going to show you how to do it. Remember, you do not have to watch this. If you don't want any extra credit, go ahead and start working on your other practice problems. But this is for people that are bored with the gram to gram. They already know it. They want to do something different. All right, so we're going to try to find out what the limiting reactant is. So we got 107.93 grams of aluminum. We have 283.6 grams of Cl2 chlorine gas. So here's our molar mass right here. So the first thing we got to do is we got to turn both these numbers into moles. So I got to turn 107.93 grams into moles. So it's always the start, line times line. What do we have? We have this. I'm going to find how many moles of aluminum first. We have 107.93 grams of Al. All right. So since we want moles, one mole is going to go on top. And notice grams is up top left, so grams is going to go bottom right. So how much does one mole of aluminum weighs 26.98. So we have more than 1 mole. 26.98 grams. All right, so now we do this. 107.93 times 1 is 107.93 divided by 26.98. And let's see what we get. 107.93 divided by 26.98. 98 equals 4. All right, so we got 4 moles of aluminum. Now let's do the same thing with chlorine. How many moles we got? This is how many grams we got, but we got to know how many moles we got. So once again, it's line times line. How much chlorine we got? We got 283.6 grams of chlorine. 283.6 grams. I'm not going to put the Cl because I ran out of space. And what does 1 mole of chlorine gas weigh? It's 70.9. We want moles, so 1 mole goes on top. We want to get rid of grams. 1 mole is 70.9 grams. All right, let's see what this equals. 283.6 times 1 is 283.6 divided by 70.9. So 283.6 divided by 70.9 equals 4. Hey, we got 4 of each. So we got 4 moles of Cl. So we got the same amount of moles of both. Now, if you look at the mole ratio of 2 to 3, but I'm just going to show you how to do it. Let me do it in red so we get another color going. All right, so I'm going to pick either one. They're both 4. I'm going to see how much chlorine we need, how much chlorine we're going to need for 4 moles of aluminum. So it's line, I wanted to pick red. Erase that. Want a different color to make it kind of stand out. Drawing red. All right, got it. All right, so it's line times line. So it doesn't matter which one you pick, but I'm going to pick aluminum. So we got 4 moles of aluminum. 4 moles. And the mole ratio is 2 to 3. So since aluminum's on top, 4 moles of aluminum, the 2 is going to go on the bottom. 2 moles of Al. And the chlorine is going to go on top with its 3. 3 moles of Cl. And this is going to show us how many moles of chlorine we're going to need to react with 4 moles of aluminum. So that's why I put the 4 of aluminum right here. Kind of, let me erase that so you can see it better. Get rid of this. So that's why I put the 4 moles of aluminum here. And that's going to tell us how many moles of chlorine we need. So 4 times 3 is 12. 12 divided by 2 is 6 moles. All right, so we need 6 moles of chlorine to react with 4 moles of aluminum. We don't have 6 moles of chlorine. We only have 4. So we need more chlorine. We're going to run out of chlorine. Chlorine is our limiting reactant or limiting reagent. All right, so that's just extra credit. And if you're interested, I can show you a lot more. All right, I will see you tomorrow in class. All right, real quick, I just noticed something that kind of, I don't know, it's bugging me, so I got to fix it. Well, I can't use my drawing tool, so I'm going to use this. All right, it's Cl2. I forgot to put the 2. I forgot to put the 2. I forgot to put the 2. So I didn't want you to have to freak you out. Like, why didn't the 2? Where'd the 2 go? It went nowhere. I just forgot to write it. All right, so 6 moles. We needed 6 moles of chlorine, but we only have 4. So chlorine is going to run out first. All right, and once again, now I'm really done.